Good day, ma'am. I am from Group 8, and I'm going to report to you Chapter 8 from the book Nature's Number that is entitled as Do Dice Play God? I'm going to start off by a phrase from Albert Einstein that says, God does not play dice. We all know that Einstein is a person that does not believe in a God because, scientifically speaking, we just believe in logic and all of those things. And the dice part here is represents the randomness and unpredictability of life and universe. It represents chance and probability. Dice is or has a limited number. When you see it, it's just 1, 2, 3, 4, 5, 6. And we as a student, we study all possible outcomes. So we can see here that dice is really that not that random, and the scientist believes that dice symbolizes life and universe. So it means that when we compare or we compare the two, we can say that life or the universe is not random in itself. So the next part is the concepts that were presented by Pierre Simon de Laplace, which is the analytical theory of probability. The analytical theory of probability states that a single roll of dice is random, but when you roll it several more times, there are patterns that are created from it. So it can be related to the Laplacian determinism, which states that everything can be predicted through or using numbers and calculations. But this has a flaw. The flaw is the uncertainty principle by Heisenberg, which states that position and velocity cannot be determined at the same time. Next is the chaos theory. The chaos theory is a branch of mathematics which states that things are sensitive to initial conditions. These initial conditions are the seed values, or when connected to the butterfly effect, which states that everything is based on initial state or the initial value. So, for example, when something is done or when something happens, you can say that something is done in order for that thing to happen. Somehow it's like that. As for the decoherence, it's just support the Laplacian determinism, the Laplacian determinism, because it is the belief that things that seems unpredictable can be predictable using numbers and calculations. So for the phase space, the phase space is believed to be the imaginary world of calculations by mathematicians, and it states here that when you place things in the phase space, everything can be calculated and put into numbers. So there are two things in the phase space, which is the attractor and the strange attractors. The attractors is the set of numerical values that evolves, and the strange attractors are the equations that represents a complex pattern of behavior in a chaotic system. Next is the period doubling. Let me correct myself. The next is the prediction. There's a part in the chapter 8 where they use prediction and defined it into two things. One is foretelling the future, and the second is describing in advance what the outcome of an experiment will be. If you think mathematically, the second phrase or the second definition is mostly used by mathematicians because in experiments, um, the second the second definition is somehow defined to be when you, even though that you know the result, you still want to do it out of curiosity. Like for example, if you, all of us know that when you put Mentos in a Coke, it will explode. But even though you know that stuff, you still want to do it because you want to see it for yourself and stuff like that. So next is the period doubling cascade. So doubling cascade is a sequence or a further sequence of doubling in a repetitive manner. So it's just like the geometry sequence in our math from our previous years in high school. It's just the period doubling cascade is just like you multiply the things by 2 in a repetitive manner. So sorry. So next is the Feigenbaum number. It's a two mathematical constant which express ratios in a diagram for a nonlinear map, and it is mostly used by approaching chaos or numbers that approaches chaos via period doubling cascade. So it's kind of related to each other. These are the concepts or the main concepts that were discussed in the chapter 8, but there are also some concepts, but most of it is just for scientific use and not for mathematical reason. So I will end my presentation here. Thank you.